on page 355. Before we start lesson 7.2, we're going to talk about simplifying radicals. Okay. Example 1. The square root of 2 times the square root of 8. Square root of 2 times the square root of 8. If you're taking the same root, okay, and all you know about now in geometry is square root, you can multiply the numbers under the radical. The square root of 2 doesn't have an answer. The square root of 8 doesn't have an answer. So we're going to multiply them together, and we're going to call that the square root of 16. Now, what's the answer to the square root of 16? 4. Okay. Next example. Square root of 294 over the square root of 3. If you're taking the same root, you can divide things if they're both underneath the radical. So this is the same as having the square root of 294 over 3. What is 294 divided by 3? Now, what's the answer to the square root of 98? Is it on the list of perfect squares? No. So the next thing you do is you look on that list of perfect squares and you see if you can find one of those numbers that's a factor of 98. Is there any of those numbers that will go into 98? 49. How many times will 98 be divided by 49? 2. So you kind of do like a factor tree. You think to yourself, this is 49 times 2. And the great thing about it is you know the answer to the square root of 49. What is that answer? You do not know the answer to the square root of 2, so you just leave it there. This is called simplifying the radical. Break it into factors. One of your factors a perfect square. Take its answer. The other part has to stay put. Okay, let's do another example. The square root of 4 over the square root of 3. I know the square root of 4. What's that answer? 2. Do you know the square root of 3? No. There's a huge rule in math that you cannot have a radical in the bottom of a fraction. So we're going to have to multiply this fraction by 1. What does 1 look like? 1 over 1? What about 2 over 2? Is that also 1? Is 3 over 3 1? Is 17 over 17 1? Is the square root of 5 over the square root of 5 equal to 1? Yes. We're going to multiply this by some version of 1. Now let me tell you what I want the answer to look like. Since I'm not allowed to have a radical in the bottom of a fraction, I want this number to be something I can take the square root of. Well, it starts out with 3. What can I turn 3 into that's on my list of squares? 9. So to get from the square root of 3 to the square root of 9, what is it that I have to multiply by? So the version of 1 that I'm looking for this problem is the square root of 3 over the square root of 3. You follow me there, Latham? Okay. Well, what happens here? Y'all have already told me that answer was 2, right? 2 square roots of 3 over the square root of 9, but what's that answer? 3. 2 square roots of 3 over 3. Let's do another one. Let's have 6 over the square root of 7. 6 over the square root of 7. I can't do anything with the square root of 7, but I can't leave it in the bottom of a fraction. So I've got to multiply by some version of 1 that will turn the square root of 7 into something I can take the square root of. You want to turn it into 49, okay? What do you have to multiply the square root of 7 by to turn it into 49? Okay. So in the top, I get 6 square roots of 7. What if I have this problem? The square root of 20 over the square root of 5. Do I have to go through all that multiply by 1 stuff in this problem? I don't if I can get rid of the square root of 5 being on the bottom. Now, I don't know what the square root of 5 is, but what's the number in the top of this fraction? Square root of 20. Can you divide the square root of 20 by the square root of 5? Remember that if you can, write it like this, and then it turns into the square root of 4, and what's that answer? 2. Suppose I have 28 over the square root of 8. What do you think we should do here? You're going to have to multiply by 1. What version of 1 do we need to multiply by? Oh, square root of 2. What are you turning 8 into over here? 16. So you don't have to go from 8 to 64. You can, but you don't have to. You could take 8 and move it into 16, and to do that, you multiply by the square root of 2 over the square root of 2. So in the top, I'd have 28 square roots of 2. What's the answer to the one in the bottom? 4. So this is 28 square roots of 2 over 4. Does that simplify? 7 square roots of 2. Okay? Keep this with you. You're going to do a few of these tonight. We're going to use them in our lesson today. Flip this over, and let's talk about the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So a squared plus b squared equals c squared. This is not new to us. This is a review lesson. If the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Now, here's what this is telling you. The one up here at the top, the one that says Pythagorean theorem, says, in a right triangle, the following situation will always occur. A squared plus b squared will equal c squared. The converse says, if I give you a triangle and a squared plus b squared equals c squared, then you can conclude that that triangle is a right triangle. Okay? Because that quality, that characteristic is there, you can go back and say, okay, it has to be a right triangle. The next one says, if the square of the length of the longest side is greater than the sum of the squares of the other two sides, then the triangle is what kind of triangle would that happen in? The length of the longest side is greater than the sums of the other two. What kind of triangle does that appear to be? Obtuse. If c is bigger, if c squared is bigger than a squared plus b squared, then it's obtuse. And if you try to do the Pythagorean theorem and c squared is smaller than a squared plus b squared, it's acute. A Pythagorean triple is any group of non-zero numbers that satisfy for example, 3, 4, and 5 are a Pythagorean triple. 5, 12, and 13. 8, 15, and 17. 7, 24, and 25. Those are not all of them. That's just some of them. Okay. Everybody caught up with me? Let's go to the next page. The hypotenuse of an isosceles right triangle has a length of 20. Find the area. Okay, so they're telling me that this is 20. And they're wanting me to find the area. Because the triangle is isosceles, what does that mean? What's it mean to be isosceles? Two sides are the same. So the two legs must be congruent. So a squared plus b squared equals c squared. That's the Pythagorean theorem. And in this particular triangle, a squared is x squared and b squared is x squared. Right? You see where they got that? And that's equal to 20 squared. We substituted x for A, x for B, and 20 for C. So I have 2x squared equals 400. Divide by 2. X squared is 200. Divided each side by 2. Now take the square root. The square root of x squared is x. The square root of 200 is written like that. Is 200 one of those numbers that has a perfect square? No. Does 200 have a factor that is a perfect square? What would that be? 100 and that's what goes right there. And 2. So what's the answer to the 100 part? 10. So it's 10 square roots of 2. So this is 10 square roots of 2. And this is 10 square roots of 2. Each leg is 10 square roots of 2 centimeters long. The legs are perpendicular. What does perpendicular mean? Nobody knows what perpendicular means? Come on now. Tell us what perpendicular means. Latham, what do you think it means? When perpendicular lines meet, they create a special kind of angle. Right angle. So the legs are perpendicular. They're creating this right angle. Now, they're really asking me to find the area in this problem. And the formula for area is 1/2 the base times the height. So you need to tell me the base and the height. We know all of the lengths on the triangle. Can you tell me the base and the height? The base is 10 square roots of 2. And the height is 10 square roots of 2. So I plug those into my formula. 10 square roots of 2 times 10 square roots of 2. Now multiply the parts that appear to match. Okay? You've got 1/2 times the square root of, times 10 square roots of 2 times 10 square roots of 2. And they want you to think of it as 1/2 times 10 times 10 times the square root of 2 times the square root of 2. So what's 10 times 10? 100. What's the square root of 2 times the square root of 2? Square root of 4. Everybody see where I got that? So I have 1/2 of 100. What's 1/2 of 100? 50. And what's the square root of 4? 2. And 50 times 2 is 100. So the area of this triangle is 100 centimeters. Okay, we're going to have to find the area of this triangle. So tell me what your strategy is going to be. I need to know the base, it's 7, and the height is what I've got to figure out. So how am I going to find that? How am I going to find this side? What would you do? What kind of triangle do we have? A right triangle. So in a right triangle, a squared plus b squared equals c squared, right? So the box squared plus 7 squared should equal the square root of 53 squared. Y'all agree with me? So the box squared plus, what's 7 squared? 49. What happens when you square the square root of 53? That 2 and that radical symbol cancel out and you just get plain old 53. What next? Subtract 49. So the box squared is equal to 4. But I don't want the box squared. I just want to know what the box is. So it's 2. Okay, so I figured out that side by using the Pythagorean theorem. Now what do I need to do to find the area? I need to know the base and the height. What's the base here? What's the height? Okay, so it's 1/2 of 7 times 2. I would multiply 7 times 2 together and get 14. What's half of 14? So this is 7 centimeters squared. Next page. Is the triangle a right triangle? How do you know if it's a right triangle or not? If it's a right triangle, those side lengths will fit into a squared plus b squared equals c squared. If it's not a right triangle, it won't work. So first thing you need to do is figure out which one you think is A, B, and C. And we don't know for sure, but we're testing it. And when we test it, we know that the hypotenuse is always the shortest side, middle side, or longest side. Longest side. So I'm going to check to see if that's the hypotenuse. So that one would be my C. So I'm going to let this be A. I'm going to let this be B. We're checking to see. Thus, 4 squared plus 6 squared equals 7 squared. I substituted 4 for A, 6 for B, and 7 for C. What's 4 squared? 16. What's 6 squared? What's 7 squared? So 16 plus 36 is 52 is not equal to 49. Is 52 bigger than 49 or smaller than 49? Bigger. Okay, so is it a right triangle? No. Now answer this question for me. Here's the question. Was C squared too little or too big? Too little. then that makes it an acute triangle. Okay? Makes it an acute triangle. Number 3, classify triangles as acute, right, or obtuse. The numbers 10, 15, and 20 represent the lengths of the sides of a triangle. Classify it as acute, right, or obtuse. Work that one. Hello. Yes, at Lamkin. Yes, I sure did. Thank you, ma'am. Bye. So 20 squared is equal to 10 squared plus 15 squared. We're checking to see if those are equal. 20 squared is 400. 10 squared is 100. 15 squared is 225. So 400 ends up being greater than 325. So was C squared equal to, bigger than, or less than A squared and B squared? So that makes the triangle obtuse. Okay. Page 360. 1 through 15 all, 22 through 34 even.